So in the lecture today, we will try to learn how to conduct the measurement of the vertical distance or the measurement of the elevation. You have actually already, oh, I haven't shared my screen yet. Okay. Okay. Some of you have already conducted experiment in the field. And the vertical distance is actually one of the important quantity for you to identify the location of one point in the Earth. And the measurement of the vertical distance is not intuitive. It's not as intuitive as the horizontal distance. As usually we need to consider the vertical distance between 2 points, and these 2 points are located at 2 different regions in the field. So we need to rely on some instrument to conduct the vertical distance measurement. Also, we have to be aware that there might be some errors, the systematic errors due to the shape of the Earth. First of all, to introduce the leveling or the vertical distance measurement, we will need to define the elevation, which would be the height of the one point on the Earth. Usually, elevation is defined as the vertical distance of one point above or below an arbitrarily assumed level surface or the curved surface. Let's take an example about the Earth. Usually, we will consider the sea level as the location with the zero elevation, and all the vertical distance is estimated with respect to the sea level, or we say that the baseline. And in this graph, you can actually find out the vertical distance from assuming that you have the level line or the sea level, which will have the vertical distance of the elevation of 0. And this is defined as the mean sea level, which is usually applied as a reference line for us to find out the elevation. And the vertical distance between point A and the mean sea level would be the elevation of A, and similarly can find out the elevation of point B. And then the difference is between these two points, between the vertical distance difference between these 2 points, is defined as the vertical distance from point A to point B. And that's usually the value we want to measure for the leveling. And so on the Earth, usually as what we specified, usually we will use the mean sea level to identify the level line, and usually if you consider the shape of the Earth as the shape of the Earth is not exactly it's not exactly in the spheral or ellipse, and also if we consider the elevation of the oceans on the Earth, the mean sea level may also not be the same. Actually, there will be some difference between the mean sea levels at the different oceans. For example, for the Pacific Ocean, it's usually about 2 feet higher than the Atlantic and the Gulf. So those would be some reference you have to consider. And usually in the for the measurement of the elevation in the mainland and in the continent, we will need to use some standard points, or we define as the benchmarks. For example, in the North America, we will usually apply the US system, which is called the National Geodetic Vertical Datum, and this one is developed in 1929. And they will have they actually measured the elevation of some reference points across different locations of North America. And those points will be defined as benchmark, which we will refer to as BM. So it's the benchmark. And the benchmark, well, depending by the improvement of the measurement technologies, we will actually adjust the elevation of the benchmark periodically. And so usually for the surveying in North America, we will check the USGS method and all the NGS reference points to calibrate those benchmarks, and then use those information to find out the elevations of the other points, or to estimate the vertical distance between 2 points, and so on. So those would be the background about the elevation that we have to consider for the vertical distance measurement. And as we know that the surface of the Earth is not flat, so the curvature of the Earth will have some impact to the estimation, to the measurement of the elevation and the vertical distance. For example, if we consider the one point A on the Earth, and as we can assume that the surface of the Earth is in a sphere, and you will find out in the level line. If we are standing at the point A to identify the horizontal line, which would be in a straight line, and the line will be tangent to point A. And then you want to go to measure the elevation at one point D. As you are standing at the point A, you will actually look through the horizontal line. Let's first ignore the impact of of your site to the distance measurement. Just consider that you can look through the horizontal line, and then what you will observe is actually a point, the point E, at the location with the point D, and you will find that the point E will have will enter the same horizontal line with the point A. So you can assume that intuitively people will assume that the point E and the point A will have the same elevation, but in reality they are different. The elevation at the point E will actually be the line D to E, and definitely this is not a zero. So we have to claim that due to the curvature of the Earth, there must be some errors exist for the elevation for the vertical distance measurement, and we have to put this one in the consideration for you to get the accurate value of the elevation. And the other things like as we are standing on the Earth, there will be some atmospheric refractions, and this one will make your line of the sides be in a curve instead of in a straight line. So your actual line of the side is not along the horizontal line. Instead, it's in it leans down a little bit. So what you will actually see along the line D to E is in the point B. And if we try to measure the elevation at this point, you will find that point B and point A will have the same elevation, but instead it's not. It actually has a certain value, which would be the distance from D to B. This would be the two errors that we have to consider. One is from the curvature, the other one is from the atmospheric refraction. At first, we will try to identify the quantity of these two errors. here we will assume that the surface of the Earth is in the sphere, so we can assume that the radius of the radius at different locations of the Earth will be the same. So the radius at the point A is R, the radius at the point D is also R. And with these settings, because the horizontal line is it's perpendicular to the line from O to A. So what we will observe is like R squared plus the AE squared will equal to OE squared. So so this is an property of the right triangle OAE, and we know that OE actually equals to R plus the distance D to E squared, and this can be simplified as the R squared plus DE squared plus 2 times R times DE. We assume that this arrow is a C. Let's assume that this arrow is a C. Then we will have the R squared plus the C squared plus 2R times C, and or you can actually remove R squared on both sides. Remove R squared on both sides, and what you will observe is like we have AE squared equal to C squared plus 2R times C. And here C is just defined as the curvature error. And this is the part we want to identify. And now let me give you an additional analysis. So in for the C, it actually consists of two parts. The D to B and B to E. So here D to B is actually the arrow that you can observe after the correction from the atmospheric refraction, and B to E is defined as the refraction error. And those are the two errors. We want the general two type of the errors in the vertical distance measurement. And then let's go to see more details. We know that AE squared equal to R squared or C squared plus 2 times RC. And with that, we can find out C equal to AE squared divided by C plus 2 times R. And here you should remember that R is the radius of the Earth. And usually the value of R is much larger than C. So we can make an approximation like the C plus 2R will be approximately 2R. And this will give you a simplification about the estimation of the curvature error. So we have AE squared divided by 2 times R. And we also know that for the Earth, the radius, we have the average radius of the Earth as 3,959 miles, or 6,371 kilometers. So with that, we can find out the simplified equation between the curvature error and the distance, the distance, horizontal distance from point from point A to point E. So with that, we will find first C will equal to AE square divided by 2 times 39, 59. If the distance of the if the distance is measured in miles, so if it's in miles, and we can then find out the our standard value. Say that if the distance AE is measured, AE is also measured. It's also measured in mile. Then we will have C equal to 0.677 times mile m square. So here m is a AE measured in miles. Well, second, so that's the equation for you to calculate the curvature error. If we know what's the distance, what's the value of AE in miles, then you can easily find out the curvature error. And another thing I forgot to mention is about the unit of this one. If you apply this equation, then the unit you calculate about the curvature error is in feet. And for the second one, if we do everything, measure everything in kilometers, then we will have C equal to AE divided by 2 times 6371. With that, you can find out C equal to 0.0785 times K square. And here K is a AE measured in kilometer. And also you can find out the unit of this one, unit of the curvature error. In this case, it's measured as it's meters. So that's the way for you to find out the curvature error. As long as you know the value of AE, you are able to find out the value of the curvature error. So now I'll give you one simple example. Assuming that we have AE equal to 100 feet, what's the value of C? Do you know how to calculate this one? Any ideas about how to find out this value? Okay. Do you know how to find out this value? Okay. Then I probably can give you the way to. Yes, the answer is right. First, you need to change the unit of the distance for AE from feet to miles or to kilometers. Here, let me just show you how you can change this one from just from feet to miles. So AE equal to 100 feet. That is 100 divided by 5,280 feet. This will give you the conversion to miles. The value is 0.0189 miles. And then you find out the AE in miles. With that, you can actually call the equation, the first equation, to find out the curvature error. So what you will get is a C equal to 0.677 times 0.0189 square. The result is 0.00024 feet. So with this one, you can actually see that the curvature error for every 100 feet is it's only 0.00024 feet. So the value is very small. Usually, if you measure some distance, if you're trying to measure the vertical distance for 2 points which are close to each other, you can ignore the curvature error as the value is very small. So any questions so far? Okay, so I saw there's one question about Manon, you mentioned about the K and M. I'm not quite sure what's the K and M you are mentioning because it's you asked the question quite early. If you can specify, I can give you more explanation. So for the in which page in the previous one? Oh, in this figure, K or M represent the two terms, that are specified in this equation. So there's another question about the how to get the convert the value from, or how to get, probably is related to how to get the coefficients and why you have the unit of the feet. This is actually a very good question. Let me give you more explanation about it. So now say that we can let's just try to make it simple. Let's say C. So now we have C equal to AE square divided by 2 times 39 59. So the one at the bottom is actually under the unit of miles, and the one on the top, you have also need to think about what's the value of the what's the unit we have to consider. Say that we consider the AE in miles. For now, we consider AE in miles, so that is m square divided by 2 times 3959, and this is a miles. And on top, you have m times m, so the unit should be miles square. What you will eventually find that you can remove 1 miles on top and bottom, so you will get m square divided by 2 times 3959 miles. And you can then convert this one to feet. Usually 1 mile is 5,280 feet. So what you will do is like m square divided by 2 times 3959. For the miles, that would be 5,280 feet. And if you do this, if you try to calculate those those constants, and what you will get is like a 0.0677 times m square feet. So that's the way for you to get the coefficients 0.677 and the unit of feet. You can apply the similar procedure for the distance in kilometers. It will give you the way to convert the unit from kilometer to meters, and also find out the value or the unit of k as kilometers. Okay, so that's the way for us to find out the curvature error. I'm not quite sure the derivation for the first one and the second one will be the procedure will be exactly the same. You just need to think about the different units for AE. Okay, also here it should be square. And the R in red represent in all this page, R in red represent the radius of the Earth. So it will be either 3,959 miles or 6,371 kilometers. They will be all the same in this page. Okay, so that's the first one, the curvature error, and the second one is about the refraction error. The refraction error is usually caused by the air pressure, the potential temperature changes, the geographical locations, and you will know that under different air pressure and the temperatures, the refraction rate of the light in the Earth will be different. So you will see that your line of the sign, the line of the sign will not be in the horizontal or not be in a straight line. So there will be some curve along the line that you observe. And this is actually a very complicated process. So in the survey, we will usually find out the average values. Generally, we assume that the curvature, the refraction error, is 1/7 of the curvature error. So that means that the refraction error BE, this is a refraction error. That usually equals to 1/7 of 1/7 of DE, which is 1/7 of C. D is just the C. And if we go to see this graph, you will find that the combined error from the refraction and the curvature will be the segment BD. So BD is the combined curvature and refraction error. And with that, we will have the BD is just the BE minus, not BE, the DE minus BE, so which will give you the value of C minus 1/7C, so that is 6/7 C. And if we know the value of AE in miles and in kilometers, you will find out the value as 0.514 m square, and this is the unit of feet, and it also equals to 0.0675 k square. This is in the unit of meters. So if AE is measured in miles, you use the first equation, and if AE is measured in kilometers, you use the second one, and you get the combined error in the unit of meters. So that's the way for you to find out the combined error of the of the refraction and curvature. Any questions so far? Okay. So this usually, as we just say that this usually happens for the large scale surveying, like when the distance between 2 points is very large, you need to think about the impact of the curvature. But usually, if those 2 points are very close to each other, we don't need to think about this impact. And next, let's go to see how we can make an measurement about the vertical distance between 2 points. Here, assuming that we have 2 points, A and B, on the Earth, and we will utilize the transit level to measure the elevation difference. And the transit level is placed at some location in between, say that location L. And we know the level line, assuming that the level line is passing point A. So this is the level line. And we also know the level line crossing point B. And then from the measurements, from the direct leveling methods, we can use the transit level to read the value or the height at point A, so which is what we read as HA. And we can also read the height at point B, that is the reading is HB. With that, we want to use all those information to find out what's the elevation difference. What's the elevation difference, which is the vertical distance between A and B. So in this case, we just assume that is h. What's the value of h? And from this figure, how will you find out the value of h? So this is the elevation difference. How are we going to find out the h? Do you have any ideas about how to use the observed values or the values that you read from this graph to find out h? First of all, from this figure, the most intuitive thing that we can observe is like h will equal to HA minus HB. HA is the elevation of point A, and HB is the elevation of point B with respect to the level line the set. And in this observation, we are given the value of HA at point A, and this is what we observed at point A, and we also know the value of HB. That's what we observed at point B, and we know that due to the curvature, we can observe we will have some potential errors. So that is HA prime and HB prime. These two are the curvature errors. Or we can, if they are long, then we can consider them as the combined errors. If they are short, we just need to think about the curvature errors. And then with that, we can think about how to find out the value of the elevation difference between A and B. So first of all, we can go to check the or to express the value of HA as the summation of capital HA, that's the elevation from from two horizontal lines, HA plus the HA prime, that's the curvature arrow. And similarly, you have little hb as capital HB plus HB prime. So here HA is the it's the elevation difference from the highest curve level line, which would be the level line of the transit level. And that's the HA represented the vertical distance or elevation difference from the point E to point A. And similarly, HB represented the elevation difference from point E to point B. And with that, we can then go to find out the elevation difference between A and B. So we have H equal, we need to recall this equation, HA minus HB. So what you will find is like HA will actually be little HA minus HA prime minus HB minus HB prime. So you can actually make some further simplification. That is HA minus HB minus HA prime minus HB prime. So this is the way for you to find out the elevation difference from point A and point B. But here, in reality, if you are doing the experiment, you can only observe or you can only read the height from the level transit. And at point A, what you're going to observe is HA, and at point B is HB. You cannot find out the value of HA prime and HB prime because this is actually the curvature error, or even though you can do the modification or calculate the curvature error. But there will be something good, some good features that you can consider to eliminate the curvature error. First, in the first scenario, if we place the transit level in the middle of point A and point B, with that we will have AL equal to BL, and we know that the curvature error is if we recall the equation, the curvature error C equal to 0.677 m squares. So m is the distance from the 2 points. So if AL equals to BL, you will see that you will have HA prime equal to HB prime, which will give you the elevation difference between HA and between point A and point B as HA minus HB. So this is very simple. You just need to find out the difference from the readings at point A and point B. And another thing, like if we are doing some small scale measurements, then we can see that HA and HB, HA prime and HB prime are very small. So we can ignore them, and we will then get the same conclusion. The elevation difference between A and B is just HA minus HB. So you just need to find out the difference between the two readings at point A and point B, no matter where you place the level transit. It's not necessary to be in the middle of the point A and point B, if we are conducting a small scale measurements. Then you can just use the difference between the two readings to find out the elevation difference between A and B. So this is called the direct leveling. And now let's see one example about the direct leveling. So assuming that we have 2 points, A and B, and the transit level is placed at some location between A and B. And at point A, we have the reading as 5.76 feet, and at the point B, it's 2.33 feet. And then we want to find out the elevation difference between A and B. To do that, we have HA equal to 5.74 and HB equal to 2.33. And then we can get the elevation difference. H equal to, this is just for the small scale measurement. So with the small scale measurement, we have H equal to HA minus HB. That equals to 5.76 minus 2.33. So it gives you the elevation difference between these 2 points as 3.43 feet. So that's the simplest way for you to conduct the vertical distance measurement. You can actually extend this measurement, this direct leveling, to multiple points, and then you can measure the elevation difference between among multiple points, and you can even find out the elevation difference of 2 points, which will be very far away. And that's what we call the differential leveling. And today we may not have enough time to go through the differential leveling. You're actually doing the experiment about differential leveling in the lab experiment 2. So you will have some sense about it, and we will continue to discuss the how the differential leveling is working, and in the next lecture. And you will also have some homework assignment about how to calculate or how to process the data from the environment. With that, I will save some time for the questions, the potential questions that you have for the lecture today. Do you have any questions so far? You can actually raise your hand if you have any questions. Okay. So are you talking about this page, Mark?
I just have a question about the refraction. So
Okay.
is that because of what's refracting? Is it our line of our eyes, or is it an instrument that we would use that would have the refraction on it?
It's about the line of the site. It's supposedly you should look at a straight line, but due to this kind of different air conditions, the air pressure, the temperature, and there are some reflections through the air. So what you will actually observe is not a line, it's actually in a curve. It's just like what you're going to see here. You are supposed to watch through in a straight line along the horizontal line, but due to the reflection, you observe the curve, and it bends down a little bit due to the refraction. And of course, sometimes it's possible to bend up a little bit, but for the average effect, usually it will bend down around 1/7 of the curvature error.
Okay, thank you.
Any other questions? Hong?
Hi, Professor. Can you hear me?
Yes.
It's not really about this lecture, but I'm just wondering if you ever talked about the quiz that we did a few lectures ago. Thanks.
About what?
About the quiz, the little quiz, 2 questions we did during 2 or 3 lectures ago. Do we have any marks or answers given to that quiz?
I think I already explained the quiz last lecture. At the end of the lecture, if you follow the lecture to the end, for the quiz, it will not be graded based on the correct answer. You just based on the attendance. We want to see how you understand the lectures during the class, and it's fine for you to make anything wrong in the quiz. And we will try to explain the answer of the quiz in the next lecture after you take the quiz.
Okay, I'll go watch it. Thanks a lot.
Yes, it's at the end of the lecture. actually the solution about the quiz is explained at the in the middle of the lecture yesterday. So for the quiz, it's actually assigned in the Avenue to Learn. It's you cannot. The quiz is only available for like 5 to 10 minutes when it's assigned. And if there's another quiz, I will let you know. And you will work on the quiz in the class, and I will try. If we have some spare time after quiz, then I'm going to explain the solution of the quiz. If not, I will save some time in the next lecture to explain the right answers.
Okay, thank you.
Good, good. Do you have any other questions? Okay. If no, then that will be all about the lecture today. And thank you very much for your time. Also remember that I have just assigned the third homework assignment. You will not have. You can start working with that. There will be something related to the differential leveling. You can go through the course materials, and also in the next Wednesday, I will try to finish the vertical distance measurement. And for the lab experiment, the due date is I can't forgot. The due date is October 18th or 17th. I a little bit forgot about it. After you finish all lab 2 and lab 3, there will be one more week for you to work on the lab report, and you have to submit the lab report 2 and 3 at the same time. Okay, I think that's all about lecture today. Thank you very much for your attention, and I will see you next week.